So the data or the distribution for the year that the pennies was minted is what?
It's skewed left.
Skewed left, okay. What else could we say?
There's a range from 1970 to 2020.
Can I say there is a range from 1970?
The range is 50 years.
Is approximately 50 years, probably 48 or so. So notice, remember, range, is it between two numbers? No, range is a single number, right? Range is a single number. So the way that Ian got that, so I would estimate probably the highest someone got was 2017. Looks like the lowest someone got was maybe 1971. Notice, and that's what you could say is, okay, the range is approximately from, so 1971 to 17 would be 46 years. Doesn't have to be that precise, but 46-ish years for the range, okay? And then, so what have I got so far in my analysis of this distribution? What have we said?
We have
the shape, we have spread using the range. Okay, we don't have the center yet.
We don't have our.
What do we estimate it would be?
Like about
probably 2000.
About 1999.
I would say, looking here, and again, do you have to have it perfect with something like this? No, if you were given values more precisely, then yes. But I would say my median may be somewhere in here. I'm thinking that's roughly half my data points. That's roughly half my data points. So maybe 2001 would probably be a good mean or median, right? But notice we've got our center, we talked about shape, we talked about spread, and we had our context. That's it. I will say, well, actually there's one other thing we could say.
There's a gap.
I would focus on the gap, right? It looks like there's a gap between 1977 and 1985.
I think I had an 87, but I forgot.
Well, you hate us, I got it. So there's a gap though between roughly 1977 and 1985. I don't see anything that would really be an outlier necessarily, but I definitely see a gap. Remember, cuss and context, okay? So I'm going to keep trying to bring that up. And we're going to use this actually for our next unit, but it takes time to build what we're doing, so that's why I'm going ahead and having you do this here. Whew. No one wrote a question, I think, because we were doing the pennies. Does anyone have a question generally before we go over the progress check?
That was my question.
About the progress check, okay? Yes, Raina.
I just wanted to make sure about I was confused about how the third block of examining and how this thing works. Are we doing third and fourth and first block in Friday?
No. Third, it'll be third and fourth still, but it'll be on Thursday. So we'll have third block, it'll be a normal day.
Normal time?
The finals will be, like if you have when we have our final, it'll be just in the morning. But when it's a midterm, it's at the normal time. Yeah, I agree, but they're not going to. So, all right. Guess that's it there. That's frozen. You can't see that. So let's go over a couple of progress check questions. Did you turn it into days? Is that what you said?
Yeah.
Yeah. I told y'all I wouldn't count it late, but I used what was turned in. We're going to finish up 6.5 and 6.6 at some point, then 6.8. And then 6.7. Star is like having his best life. We won't get there today. All right. So a couple of things I want to talk about with this one. So this is one of the two more difficult questions. And so if you haven't done the progress check yet, you need to do that tonight. I wasn't going to count against you because I forgot to post it. That was my fault. But this is one of the harder questions a lot of times for people. But that's because we forget to pay attention to what this is actually saying right here, okay? What are these probabilities? Cumulative, right? Notice, when we talk about cumulative, we're talking about like a cumulative relative frequency. So the probability that the random variable x equals 1 is 0.2, but what's the probability that the random variable x equals 2?
0.5.
0.6.
Not 0.5.
0.3.
It's only 0.3. Because this is the probability of the rated variable being 2 or less. So that 0.5 is the 2 and the 1. And if the probability that, if x is 1, then the probability that x equals this value, okay, so that's still 0.2. But we went from 0.2 to 0.5, which would give me 0.3. We went from 0.5 to 0.6, so it's 0.1. 0.6 to 0.7.
0.1. 0.1.
So we need to recognize, and this is a more difficult one for a lot of students, I get that. But you would need to recognize that this is a cumulative relative frequency. This is not the relative frequency, which cumulative, when I say relative frequency, is very similar to probability, because remember, probability is just a long run relative frequency, okay? Now, when we look at this, can anyone tell just off of these probabilities what shape this might have?
Right.
It should be skewed right. So if we check it, so here's 1, 2, 3, 4, 5, 6, 7. The highest that I get is, well, actually, let's do this. 0.2, 0.4, 0.6, 0.8. Okay, so what I'm going to do is I'm going to start with 1 is 0.2. Boom. 2 we said was the 0.3. And I know this sounds goofy that I did this scale. I'll explain why in a second. Because we don't ever get above 0.3. Everything else is a 0.1. Boom. Okay? We can see now, how would I describe this distribution?
Skewed right.
It is skewed right, and what else can I say about it? It's not asked here, but what else can I say?
Unimodal.
Unimodal. It is skewed right, so what about the mean?
It'd be, the mean would be
It'd be
higher
like
than
30 or
median.
4 or 5.
The mean would be what?
It'd be like 30.
Probably
Slightly less than 4.
slightly less than 4, so the mean equal to 4? Well,
So it's
hold
mean.
on. Well, I don't know why they're using 4. That's not what I would have ever referred to. But what was it?
It was E.
E, skew to the right, with a mean less than 4. So I guess I see why they're saying this. So where's the 4 even coming from?
It's like right smack dab.
It's right smack dab in the middle. Now, for those of y'all who are planning to do a retest, which most of us should be planning to do a retest on Unit 2, most of us need it, what I would point out is, where's the median in this distribution?
Oh, 3.5.
Between
It's not 3.5.
2, 3.
It's right at 2. Maybe somewhere between 2 and 3, but remember, what does a median do? Because we talked about this earlier, Ian.
It's resistance outline.
Well, but it's also separating the bottom 50% from the top 50%. So right here, and this isn't exactly a relative frequency, it's a probability, but it's a similar idea. Isn't there, right there, the 50th percentile, right? My cumulative relative frequency at the end of 2 is 0.5. So my median is 2. Now, so what they're doing is they're saying the mean, they're trying to get you to realize that it's not the middle of 1 and 7, right? It's not that 3.5 for the mean. What I would have done is, I would have referenced this too. Where's the mean going to be in respect to that median of 2?
It's gonna be higher.
It's going to be higher. Why would the mean be higher than that 2?
Because it's skewed.
Right.
It's skewed to the right, and the mean is pulled in that direction of the skewness. Okay? Now, because I saw this for a couple of us as well at different points, we've got to remember skewness is in the direction of the what? Not necessarily the outlier, of the tail. Skewness is in the direction of the longer tail. We've got to recognize that skewness is in the direction of the longer tail. So again, trying to recap some things for those of y'all trying to retest. Skewness is in the direction of the longer tail. So skew to the right, so the mean is going to be greater than 2 for sure. It's skewed to the right, so I know the mean has to be greater than 2. It's not going to be out to that 4, so it'd be less than the 4. All right.
Why? Like, why can't it be greater than 4? Because that's what I put.
Okay, so where median separates the bottom 50% from the top 50%, a way to understand the mean is that the mean, I'm trying to think of the way they talk about it in the book that I've seen. It separates the weight, is the way we usually talk about it, in 2. Now I want you to think about it. If I put the mean right here, is this itty bitty weight, even though we got some large values over here, would that weight be the same as this weight?
No.
No. Okay. The other thing I would point out is, does anyone know an easier way to find the mean? I should have thought to say this earlier.
Multiply by the probability.
Right. Isn't the mean
It's not easy.
the sum of x times the probability of x? So that's a hint for y'all that we should have thought about is, if they're asking about the mean, well, you need the probability of those individual values as well.
Okay, makes
But if you
sense.
find those, so it'd be 0.2, 0.6, 0.8, 0.9, 0.9, 1.3, 1.8, 2.4, 3.1. So if you literally do the means, it gives you the 3.1 mean. Notice that mean, is it greater than this 2?
Yes.
Pull it in that direction? Yeah. Is it all the way out to this?
No.
4? No. It's only 3.1. So use that to find your means. But again, notice cumulative relative frequency. And again, I did some review there. Hopefully that helps some of us. Okay, this is one of the most missed questions. In fact, I don't think anyone actually got this question right. Yes, Sophie?
Okay, wait. Why do you, for the graph, like, why do you use the difference between?
Oh. This, why did I use that scale?
Well,
Oh.
like, for 1 you did the, wait. No, for like the 2 you did the 0.3.
This one? Because remember, this is cumulative. So 0.2 of it was when x equals 1. So what is x equaling 2? Only 0.3. That, you add those together, that's this 0.5. So it's the cumulative idea. Plus that 0.1 is how we got 0.6, right? So getting rid of that cumulative. Okay, sorry, I also meant to point this out. This is why I did this scale here. Notice, this is a cumulative relative frequency graph, is literally what they gave us, right? Like if we had actually graphed those points, they gave us a cumulative relative frequency graph. We should notice by the end, what probability did we have? 1, which is everything, right? That's a big hint that should have told us, hey, these are not individual probabilities, this is the cumulative probability. Because when you have the probability, the sum of all the probabilities in the sample space, you get 1, and that's everything, okay? So, sorry, that's why I did that scale, is for y'all to see, like, the purple here is the histogram for each individual value. The orange here is my cumulative relative frequency, or probability in that case. All right, thank you for that. That was fantastic. All right.
So, well, are you not gonna tell us the options?
What? What options?
I'm just talking about the options, A, B, C,
What was that? It was E. We already talked about that. Someone else said it was E.
I
also.
said it.
Notice the distribution is skewed to the right. And remember, I literally did the calculation of the mean. The mean was 3.1. So like 4 is all the way out here. Like the middle of the scale is not the mean. The mean would have to be further to the left. Okay. All right, number 14. Regularly, every year, this is one of the more missed questions. And we forget to pay attention to the language, because the language here actually tells us everything. It asks us which of the following statements about random variables x and y is true, I think, or is correct. And the question doesn't tell me a lot, but look at the answer choices. What are all the answer choices about?
Independent or not independent?
Independence, right? Hey guys, if they're independent, what is the probability of x equaling 1 given y equaling 1 have to equal?
1.
Well, the probability
It's
of
1 times 1.
probability of what?
X times y. Wait.
X equals 1. This is the conditional. What you think about is probability of X equals Y and Y equals Y. Then I would multiply them.
Oh.
Because if they're independent, does this condition matter? No. Okay, let's find the probability that X equals 1 given Y equals 1. Okay, well, that's probability of X equaling 1 and Y equaling 1. Remember, can I assume independence? No. So, but literally I have the intersection right here. What's the probability that X equals 1 and Y equals 1? 0.04. What's the probability that Y equals 1? So I gotta add these. 0.12, 0.24, 0.4. Yeah, you need the total, right? Okay. Now, if you take the time to divide these, you get 0.1, I believe. Yeah, 0.1. And then what's the probability that X equals 1? So I need to add all these up. So 0.07, 0.09, 0.1. Are those equal? So are they independent events?
Yes.
Yeah. That's it. X and Y are independent because knowing the value of X does not change the probability distribution of Y. So I will point out, so I do want to pause and point this out. We should have immediately been able to eliminate B and D. Why should we have been able to eliminate B and D? Yeah. Well, not just because it's saying not independent. I should be able to eliminate B because it says X and Y are what? Are independent because knowing the value of X changes the probability distribution of Y.
It's contradictory.
That's contradictory, right? Like, those are things we got to pay attention to. If we're saying that they're independent, one does not affect the other. Whereas here down in D it says X and Y are not independent because knowing the value of X, wait. Yeah, that's not con. Is it this one? Yeah, it was C that I meant to eliminate, sorry. Yeah, sorry. X and Y are not independent because knowing the value of X does not change the probability distribution of Y. Those are contradictory to what independent and not independent means. But again, like once we see this idea of independent, we need to be thinking about conditional statements. Does that condition matter? And I don't have to check all of them, I just check one. What I would point out is literally if you, because it took me a while to realize this, but isn't this double 0.04?
Yes.
Isn't this double 0.03? Double 0.02? Isn't this triple 0.04? Triple, triple. This is 4 times, 4 times, 4 times. So it didn't matter where I was, like it was always going to have that ratio or that proportion, right? So, yep, they were independent events. Now, those are not what impact us a lot for this DYU today. This is the one we really need to focus on. And this was a more heavily missed question. And so I'm going to give you all time to work in your small groups on this question a little bit. I'll have it up here. But let's read through it. Biologists are analyzing soil to check for the number of worms and grubs in a wildlife preserve. Let the random variable W represent the number of worms. So I'm going to label this as my worms. And in 1 square foot of soil. Let the random variable G represent, bless you, the number of grubs found in 1 square foot of soil. The following table shows the probability distributions developed by the biologists for W and G, right? So 0 worms, 0 grubs, 1 and 1, and then we have their probabilities. Assume that the distribution of worms and grubs are independent. What are the mean and standard deviation for the total number of worms and grubs? This is one of the things that we need to recognize. What are we doing with W and with G? Combining them. This is that clear-cut case of we are looking at W plus G. We need to recognize that. And so if I want the mean of W plus G, how am I going to find the mean of putting those two random variables together? Adding what though? Adding their means. Didn't we talk about that yesterday where the mean of adding the two random variables is just the sum of those two means? Okay? So then when I look at the standard deviation in a second, The standard deviation of worms plus grubs is just standard deviation of worms plus standard deviation of grub, right?
No.
Why not?
Because that's only for,
It's what?
That's for
It's the square root of the variances. Remember, we can't add standard deviations. What theorem did I tell you or point out to you yesterday that it follows? Pythagorean theorem, right? The idea is that we're looking at distances. And so the variance of worms plus grubs equals the variance of the worms plus the variance of the grubs. So what are you going to have to do in order to figure these two things out?
graph it.
I'm not graphing
You're
it.
gonna use the lesson spreadsheet.
I'm going to use less than the spreadsheets and the calculator. So let's work. Mr. Anderson and I will come by and answer questions if you have them, and help you do this one, because you've got to know how to do this for your DYU. Well, you need to know how to find mean and standard deviation for sure, and there will be at least one combining random variables.
I took one, forgot about it.
Okay, how do you all of these?
You would have to run them separately, right? You'd have to do two different lists, two different sets of probability, and work through it that way. But if you see two random variables, okay, straight up, if you see two random variables, I personally always write it this way right here. And so please hold on to this, because this is going to matter in 2 units. Actually, maybe next unit as well, but definitely in 2 units. Where, okay, I'm looking for the mean of worms plus grub. Okay, that's just mean of worms plus mean of grub. If I'm looking for the standard deviation, I just have to remember that I can't do straight standard deviation. I have to do the variance, because we're talking about distance, we're talking about the Pythagorean theorem, essentially. Okay? Now, how would things change? It didn't here, so I'm going to talk through this in a second, but how would things change if it was worms minus grub? So, well, hold on to that, but like, over here, how would this change if I did worms minus grub?
It would be like
No, like, what would happen differently in
Would
this
you just
formula?
subtract them?
I would just subtract them.
That's what I just.
Okay, I didn't hear you, my bad.
No.
Notice, we're just going to subtract the mean of the worms minus the mean of the grub. How would it change over here with the...
It would.
It wouldn't. Remember, I talked about it yesterday, I explained the idea of using entropy, which did y'all give a shout out to Mr. House for me? Man, why do y'all hate me?
Yeah, me too. He did say something. Yeah, he did say that.
Anyways, entropy, chaos always what?
It
Increases. We're not going to decrease our chaos, right? So, it doesn't matter that it's subtracting here. We're going to add our variances still, right? Chaos only increases, okay? But, we're doing plus, and just add it together, alright? Now, real quick point here. I cannot emphasize this enough. This right here is why I only use z-scores, okay? Because this is a lot of weird numbers. And I'm not saying that this is what this problem was asking for. We already have the answer. The answer was C, I think? C, okay. But if it was asked of me, hey, what's the probability that the number of worms plus grub is greater than or equal to 8? Yeah, that seems really big. Let's go 7, okay? Well, the probability of worms plus grub is greater than or equal to 7. If I was doing this, and it's a normal distribution, okay? Which is not actually in this case, I'm just kind of saying that right now. But if it was a normal distribution, I would have to do a mean of 5.28, I'd have to do a standard deviation of 1.67, and that's a pain in the butt. I can't believe like Star hasn't been freaking out this whole time.
I just realized it was. To be honest, I only picked it because it said it.
Notice how much easier it is to make that distribution, okay? So I would just convert this to a z-score. So z equals 7 minus the mean of 5.28 divided by the standard deviation of 1.67. If you convert everything to z-scores, it's way easier to put on a normal distribution. Okay? And when we study some stuff later in inferential statistics, it's going to matter there as well. Okay, last one.
Can you tell number 1?
Huh?
No.
Number 1?
Stop.
Number 1's not on this DYU, but I can look at it with you later. All right. So Parker has a part-time job picking apples. Let the random variable A represent the number of baskets of apples he picked each day. The distribution of A has a mean of 4.5 baskets. So mean of A, 4.5 baskets. Okay? And a standard deviation of 1.3 baskets. So the standard deviation of baskets is 1.3. Notice, I just want to point out, like I haven't even finished reading through the problem, but I'm writing out key information that I'm going to need later. Okay? So I can come back to it. Okay. Now Parker is paid $65 per day plus $5 per basket. So what are the mean and the standard deviation? So I want to point this out. First things first, am I combining random variables here?
No.
What is this? I'm transforming. Notice, last time we took worms and we added grubs to it, right? The worm was a random variable, the grub was a random variable, right? But these aren't random variables. What are these? These are, these are constants, right? This number of 65, that's a constant, right? This 5 is a constant, right? So I am transforming a random variable. That's it. What do you mean what? You good? What's throwing you off?
Transforming.
Okay. So remember, transforming is the idea of adding or subtracting by a constant.
Oh, never mind.
And multiplying or dividing.
Never mind, actually,
Okay, you good now? Alright, so with that in mind, we're transforming. Does anyone know how I could, and so there's a few different ways to think about this.
Peter.
Hello.
I left something in here.
You might want it, I hope that it's still there.
You
Okay.
just struck.
Okay, so really quickly, looking up here, what's going to affect the standard deviation?
The multiplication and dividing.
The multiplication. Okay, so where are we multiplying here?
5.
Why is it the 5 and not the 65?
Because it's
It says per day.
Because 60 times is a flat rate.
Guys want to
So 65 is the flat rate, but also remember, what's your variable? Baskets. It's the per basket. It's the idea of the per basket that's going with that, okay? All right. The per day is a flat rate. It only happens once, okay? So what I would do in this case is I would actually write out an equation. What I would point out is we are looking at his pay. Isn't his pay equal to 5 times however many baskets he has plus $65?
Correct.
Like that's his pay for the day. Okay? So what would be the mean pay for the day? It'd be 5 times the mean of the baskets plus 65. Notice the order does matter. We're going to multiply first and then add. And so you have 5 times 4.5 plus 65. What does that give me? 8750, I'm guessing?
Yeah.
Okay? So it's an 8750.
You can mark out the 20s.
So remember, both the multiplier and the addition affect the mean. But what's going to affect the standard deviation of the pay? Only the multiplier. So 5 times 1.3?
7.
What's 5 times 1.3? The original standard deviation was 1.3, and each basket is $5, so the standard deviation is $6.50. So we're transforming the random variable, okay? So 2 things I'll point out is, okay, you can write an equation like this using a linear transformation, y equals mx plus b, essentially. You can write an equation like this and then just realize that the mean is affected by everything and that the standard deviation is only affected by the multiplier. Or you can recognize, hey, the mean is 4.5 baskets and I make $5 per basket. So the mean at that point is $22.50. And then each day I constantly am getting $65, so I add 65. So that constant addition is not going to affect my variability, my standard deviation, just the multiplier by 5. Okay? So those are transformations and combining random variables. And that's all I got here. And we definitely do not have time to do the DYU. So we'll do that right after lunch.
We could definitely fix like.
We do it in 2-3 minutes?
Yeah, 3 minutes.
Yeah.
Listen,
Okay.
it's the oral.
So here's what I want you to do really quickly. Okay, so this is the next lesson. We're just going to do the very bare minimum introduction. So with this right here, so let's go pop quiz. And by pop quiz, this is lesson 6.6. Okay? I'm going to set up the context. I want you to do this first little piece, and then we'll look at it after the DYU. But let's say it's time for a pop quiz. The quiz consists of 5 multiple choice questions. Each question has 4 answer choices, labeled A through D. But you're not going to get to see the questions. So you just have to make your best guess for what the correct answer to number 1 is. So fill in one of the bubbles for number 1. Fill in one of the bubbles for number 2. Fill in one of the bubbles for number 3. So just fill those in, okay, for what you think the correct answer might be. For 1 through 5. So just bubble in A, B, C, or D for numbers 1 through 5. You see a path? That's impressive because I don't.
What are you doing?
I'm visualizing the answers.
Dog, just pick something. You know you're gonna have to guess.
Question correct, higher.
I'm getting these right.
Wait, are they all the same answer or are they different?
I don't know.
Does that really help?
He don't know.
Okay?
Wait, can we get bonus points if we get the most correct?
No.
Bonus points?
I need total focus.
Okay.
Is it raining?
No. Wait, yeah.
Yes.
It's been
It's snowing. It's snowing.
It is not snowing, my guy. Alright. So, correct answer, number 1 is A.
Oh. I got A.
Correct answer for number 2 is D.
Hey! Dang it, I got A.
Correct answer for number 3 is A.
Oh.
Yes.
Correct answer for number 4 is B.
No!
And correct answer for number 5 is B.
No!
So, right now at number 1, how many you got correct? We'll come back to this after we do the DYU after lunch.
It's by number.
Either you get it right or you get it wrong.
People who make all A's can be employees. People who make all S are bosses.
I got 2.
I'm not gonna put
Oh, I should take a look at those 3 questions right.
I really thought they would think, they would think I was gonna take
Oh wait, I'm really care what I was
trying to like outthink them. They're lonely knives now.
Okay, so let's write a few notes, not on this. I'm going to come back to this in a second. So, first things first, 6.1 to 6.4 DYU tomorrow. Okay? That's going to push the 6.5 to 6.8 DYU to Friday. Is that what I said? Yep.
Does that mean you said we get to the 6.7?
The test, the unit test, yes, we'll do 6.7. The unit test is going to have to be next Thursday. Because we are out Monday, Tuesday. We have work keys / pre-ACT on Wednesday. Not the middle of,
Do not make it.
middle of third block, right? All right, test. What is that? 4? No, not 4. 10 / 16. Whatever that Thursday is of homecoming.
The 16th.
Okay. The reason why we're doing this is to give you more time to practice and get things done. The bad news is I will not be here on that Thursday. Okay. I will be at a conference. I'll actually be presenting that morning and on Friday morning. So I will not be here, but that also means that this part 2 of probability will not be on your midterm. Only part 1 of the probability will be on your midterm. Okay, so only part 1 of the probability. Now, all that to also detail, let's do this. Thank you so much. Wait, this Thursday, Friday, yes. I am going to explain your next project tomorrow. Okay?
Wait, I have a question.
Hold on, okay? I'll answer the questions in a second. Okay, so next project, I'm gonna explain it tomorrow. That next project is going to be actually you creating and conducting your own study. I'll give you more parameters for that. So I'm gonna explain the next project tomorrow. You will be turning in a rough draft of your study design on Monday. It'll be on Schoology, okay? The reason why is,
Next Monday?
yes, next Monday. And it's just the study design. It's not the collecting of the data. It's just, what is your question and how do you plan on collecting data to answer that question? The reason why I need you to turn in that study design on Monday is because you are actually going to collect the data on Thursday, Friday. So next week, so you're just going, and I'll explain more about this, but I just want you to be aware of this timeline. You're just doing a rough draft of the design. Like, what is the question that you want to ask? What's your plan to collect that data? Then you're actually going to go through the data collection process next Thursday and Friday. I will reach out to some teachers to see what teachers would let you come in and maybe ask their class questions, things like that. Maybe collect data during lunch or something to that effect. And then that's what we'll be doing there while I'm gone. Okay? Yes, Raina.
Just to make sure, when is our first project due?
Officially, what, tomorrow, right?
Tomorrow night.
If you turn it in, I will not be getting a chance to read the projects until Friday, so as long as you haven't turned in by Thursday night, I'll do it. But I would try to get it done ASAP, yes. The midterm factors into part of your test grade. What's your question? The project is 20%.
So is it due tomorrow morning or tomorrow whole day?
I just said as long as the paper is turned in by Thursday, I'm good.
Okay.
Even turned in on Thursday, I'm good. I will not get a chance to read until Friday.
What'll be it,
As long as it's turned in Thursday,
Thursday night, got it.
I'm
got
good.
it.
This is why you listen when I talk, because I said realistically I won't get to read it until Friday. So as long as it's turned in Thursday, I'm good.
My classmates are confusing me.
Okay. Last thing, okay? Retest. These need to be done tomorrow, which only one person is one person has done a full retest, one person has started a retest. I mean, and I guess like realistically Thursday, Friday, I just don't want you to have to do it in the middle of midterms. But like we need to take advantage of the retest. Like we need to have greater evidence of understanding. If you need to come in before school, I'll get yelled at and skip morning duty. I don't care. Stay after school. Whatever you gotta do. But like we need to be doing retests because one, I want you to earn a higher grade in this class. But more importantly, like I want you to master these ideas so you're better prepared for the actual exam. And like I know we have all next semester to review and prepare for that exam, for the AP exam. But like realistically, the majority of what you're gonna get is this semester because you're gonna have other classes next semester. So I don't wanna like leave that. I want that to be a maintenance thing, not a learning new thing. So please ask the questions. Y'all were good on bivariate data. You will need to review at times. I'll incorporate that. Some of y'all need to do a probability unit 1 retest. Some of you need to do a unit 2 univariate retest. Some of you need to do both. But like, I'm here to help you be successful. We need to take advantage of the time we have. Okay? Please come talk to me if you need a plan. But we got to get a plan to master these things, and we're going to get started with this. Yes, Raina?
So if you have if things get so unfortunate and if you have a not really good grade as the first test and the retest with the better grade.
Make a better grade. Don't let that be an option. Master the ideas better and make a better grade. Okay? We're not doing the ifs and buts. We're not going down. We're improving our understanding. Okay. Bubble in an answer for each question for the pop quiz. How many people got 0 right? How many people got 1 right? 2? 3? 4? 5? Alright, so bubble in, so how many did you get right? Let x equal the number of correct guesses. Is this a binomial setting? Calculate the probability of getting exactly 2 correct. Work with your small group on answering those next 2 questions. And we'll talk before you complete the table. So just a couple minutes, answer 2 and 3. Work with each other.
So,
Yep, so is it a binomial random variable? Talking about that binomial setting though, I need you to not just write out BINS. BINS is an acronym to help you remember if it's binomial or not. But what does that B stand for?
binary.
Binary, okay? So correct or wrong. Notice I have shown that it's binary. Independent.
It doesn't affect the other.
One question doesn't affect the next.
Number of trials is fixed.
Hold on, not quite there. Doesn't affect the next. Notice I'm actually explaining how it is binary, how it's independent. Number of trials
5.
is fixed at
5.
Yep.
Is it okay to say fixed by 5?
Well, 5 trials, something. Okay. So, and the last one,
Safety.
same probability. What is that same probability?
1/4.
Of 1/4 of guessing correct. There we go. I have satisfied BINS. So is it binomial?
Yeah.
Yeah. So calculate the probability of getting exactly 2 correct. Now, here's where I want you to, and this is what the AP exam will probably want, they actually want you to write out the formula. You don't have to necessarily use the formula, but you need to write it out. So first things first, what's the probability notation that I should use here?
Probability of x is correct. And then complement of correct. Or,
Now, you say x equals 2, but what is x?
number of correct.
Number of correctly guessed questions, or something to that effect. If you're going to use an x or a random variable, you got to define that random variable. So define your random variable. So don't just say x equals 2, don't just say y equals whatever. Make sure you define that random variable. Now, what is that formula that we looked at yesterday? N, choose x. Be careful, it's not an over, and this is again, like if you ever come into one of my regular math classes, you will never hear me say the word over, because over means nothing in mathematics, okay? Like, I know you're like, well, Mr. Kennedy, that's 2 over 3. No, that's 2 divided by 3. Like, division means something, or 2/3, it means something. And again, like when you say over here, it's like that over and that over are not the same thing. Does anyone remember how we read this actually? N, choose x, or n combination x. Okay, so n choose x is the main thing. Remember, there is a formula for it. Do you need to know the combination formula?
No.
No, right? But it's n choose x times. Hey guys, don't forget, y'all have a formula sheet. Times p raised to the x times raised to the n minus x. Okay, remember what this is saying is my number of what? Trials. X is my number of successes. Okay. P is my probability of success. Again, X is number of successes. If P is my probability of success, what's 1 minus P?
Not successful.
So probability of failures, right? Not successes, probability of failure. And then n minus x is the number of failures, right? The total number of trials minus the successes gives me my number of failures. Now, that means I need to actually write that out here. So what is n again?
5.
We have 5 questions, didn't we? Okay, x was my number of successes. How many successes do we want?
5.
2.
Oh.
Remember, it's the probability that x equals 2.
That's 6.
So 5 choose 2 times, what's my probability of success?
4. 1/4.
1/4. By the way, don't forget, like, the reason we write this formula out is so you know what to plug in, right? P, my probability of success. What's the next piece? I need the,
The number of successes.
so 2, number of successes. That's what that x is, 2. Because remember, we want 2 successes, so that'd be 1/4 times 1/4. Remember, we looked at working that out yesterday, okay? 1 minus p. Now you can go through all the work, but like if 1/4 is probability of success, what's probability of failure?
3.
3/4.
3/4. And how many 3/4 are we going to have?
3.
3. That's the 5 minus the 2. That's 3. Right. So all it is substituting into that formula. But again, I'm not actually going to use this formula. The AP exam wants me to show that work, but I live in the 21st century.
I'll come to that door.
Grab that calculator.
What about calculator?
Okay.
So how do I put 5?
So make sure you make what kind of page?
It's 5 choose 2.
A calculator page.
You need a calculator page. So guys, once you get your calculator page, so don't forget, same button is where we want to start every time. What's the button that lets me do cool crap?
Menu.
Menu. What branch of math are we dealing with right now?
Probability.
So notice we're going to probability. And we call this a binomial what?
Combination.
Well, we used a combination, but remember a combination is only part of it. I'm not even going to worry about the combination right now. It's a binomial what?
Distribution.
Go to distributions. Remember, this is a binomial distribution. The language matters. Notice when you go to binomial distribution. Say that one more time. Say CDF. Okay. Remember, what does that C stand for?
Cumulative.
Cumulative. So that means more than one thing, right? How many do I have? Just 1. So it's 2 successes, but that's only one value for the random variable. So go to PDF. This is one of the few times we're going to go to PDF. Notice it asks for just those things. Number of trials is 5. Probability of success is 1/4. And my x value is 2.
Why aren't you using CDF?
Because I only want how many successes?
Oh, PDF?
I only want 2. I don't want multiple options of success. I only want 2. That's only one option.
0.2.
Okay, I'll show you something else in a second, but I want PDF, probability density function.
3, 35, 2, 56.
Yeah, because what are you doing, Sophie?
Wait, so
Why
it's
do you
like-
have like, 5 brackets?
No, it's 5, 1,
Oh, yeah, well, you know, it's all- yeah.
Go to menu, probability, distributions, hit A. Number of trials 5. Probability of success is 1/4. X value is 2.
Okay. So, 2 things I'm going to show you, because I want to show you, Raina, one reason why we need to know it's a PDF and not a CDF. But I want you to notice, like, what I've done right here is I've written out the work using the calculator that says this right here. So the calculator does this NCR, but 5 choose 2, 1/4 to the second, 3/4 to the third. What should I get when I hit enter in a second?
0.26.
2, 6, 3, 6, 7, 2?
6,
Well, let me actually get the decimal version. Is that what I got? Yeah, that's exactly what I got. Now, Raina, you're asking about CDF, so pause on the calculator and look. If I go to CDF, okay, so we will do CDF at some points, but CDF knows it's still 5 trials. Probability of success is still 1/4, but notice it now asks for a lower bound and an upper bound. It's not 2 or more, it's not 2 or less, it's just 2. So when it's just one of the options, it's a PDF. CDF is cumulative. So like 2, 3, 4, 5. Does that make sense? So a CDF is more than when there's more than one set of successes that you want. Okay, PDF is when you're just looking at one. So a quick hint on that, if it says x equals 2 or x equals 4, it's a PDF. If it's an x is greater than or equal to 2, then that's accumulation of things, that's a CDF. Okay. So, calculate the probability of getting exactly 2 correct, I don't remember what it was it 0.26 something?
0.26367
Okay. Alright, so there we go. And this is how I know Star's asleep just about, because he didn't giggle about his 6-7 up there. But, that's it. We use calculators to make our life easy. Notice, the biggest thing with these is you have to recognize binomial. You have to recognize binomial when we get started. And then use the calculator. So, now, complete this table. We already have the 2, right?
Yes. Oh, sorry.
Okay, find the rest.
Why did I get it wrong about it?
Guys, I got you.
Wait, I want to find this.
Because 5 choose 2.
5.
Right here. 5 choose 2.
Isn't probably
It's 10.
Isn't the probability of getting
What are
one?
you
So
doing?
5 factorial divided
Actually, what are you
by
doing now?
3 factorial
Give me
times 2
your whispering
factorial. So
number.
this is n
I mean, not the
divided by
probability of
n
getting
minus
one,
x.
So don't lie.
5 factorial, so what I'm going to do is I'm going to do some shortcut math. So I'm going to stop it. So factorial, remember, is 5 times 4 times 3 times 2. So that's my 3 times 2.
You had no. Yes.
I like your
3
I
factorial.
can't hear like words. I feel like
And 2 factorial is just 2
I'm
times.
pretty sure every single time that someone says success,
What's 5 times 2?
6-7 with it.
So this would have multiplied that by 10. Because all you did was the probability of success to the number of successes, probability of failures to the number of failures. And you forgot that there's 10 different ways to do it. Right? So we multiply by 10. Yes, Andrew?
How do you do, I always get the error.
Yep. Nope. That's actually, that's something I'm going to show you all later.
What?
Okay?
No.
So, watch this.
So you have,
5 probability. Let's go 5 distributions, and let's go to A. So what we have are 5 trials, 1/4 for our probability of success, and you didn't put the x value in, right? So put a 0, well actually put a 0 right now. I'll explain why in a second. Notice that's 0.2373. Yeah, look at the very first number right here. That's all of them already done. So now if you're trying to do the whole probability distribution, that's what you want. If you only want one of those numbers though.
Don't tell anybody else.
Okay.
just probability of success, or not like that.
What are you talking about?
Okay, what did you get?
I can't help you if it's gone.
Look. Like, where
Oh,
are you
I
gonna
mean,
be?
okay, so
Okay.
it's like 1
Okay.
x to this, 3 towards 1 if it's 5 x.
0.
So the number of trials is 5, right? Okay. Probability of success is 1/4. And how many successes? Did you? Enter. Sometimes things go wrong, but we must know when we get back. But it's like if I don't see what went wrong, I can't explain what went wrong. So just hold on to it so I can look at it real quick.
So are you, am I putting this here or?
Well, no, that's for 1 success.
I'm just trying to act nonchalant with you.
Yeah.
So, but why aren't you doing it?
Don't.
Then you are doing that when the calculator's doing it for you.
Oh.
That's the 2 right here. But the calculator does all that work for you without you having to do it. Be careful.
Bro,
It's
how
not
do you get
practice.
the pouch?
Oh, yeah.
Wanna check my grade? I'll let you.
All right. So, hey, by the way, guys, if you're done with 4, move on to the rest of this page, right? We should be able to get all of the. Oh wait, hold on. Yeah, you can get all those things now. Okay.
That's all of them.
So it's
That's so insane.
Someone never goes to the pages.
Cool, right? Come on, wanna open up your list in the spreadsheet, bud?
Hey, for.
Oh, you guys can just.
I know, I don't know, that's okay.
What?
The mean.
From P.
Oh, but you do 0 times, you do 0 times 1. Put-
0.6,
Nope.
3, 5.
Oh, okay, so for your gain, is that just probability? Okay.
So, by the way, just in case we weren't aware of this, how are we gonna find our mean and standard deviation for numbers 5 and 6? So yeah, do this in your list and spreadsheets, okay?
Okay, what was this?
Increase standard deviation is, 0.96. That's what, 4, 6.
Ian.
Yes.
See?
That's not right.
Me, I'm a.
You don't know how to interpret the mean? I think it's, the average person gets about 1.25 questions correct. And in many trials. But like in many trials, it probably would have.
The mean is, I got the mean as 1.25.
0.014, 648.
You should.
Interpret.
It is not very good.
Average,
That's 60.
that's,
I want to get to name my list. That's the first thing I do.
No, that's long run relative frequency. The mean represents the average or central value of the data set. So it's the middle.
What are the, it says use technology.
Mr. Kenny, can I move seats?
Can you what?
Can I move seats?
Who's bothering you?
Andrew, ew.
What?
He's bothering
yeah.
me.
Yes.
Right.
He's
Just tell me
the.
it's each of
Now
you.
whispering 16.
Ooh.
He's bothering you.
Come on, Dick.
Bro, I'm gonna do a little switcheroo.
Get out. Get out.
Hey, let's focus on the math, please.
Can you focus on the
Mr.
math?
Kenny, don't talk, because you added fuel to the fire.
Oh, I think that
That's my bad.
Wait, what'd you say?
I've never heard that.
Guys, the standard deviation. 0.9.
What?
What is the probability of at most
What was-
3 correct?
Why? I don't know why, but I got that. I replied to you and it has an error. I did the calculation the right way and it said it has an error.
Please fit me?
No.
Like, not at all?
Not at all.
Alright, to make sure you have your calculations right, there's your mean and standard deviation.
I'm trying.
So make sure you check your mean and standard deviation once you write it down.
What? I'm going as fast as I can.
You're good.
I did
Kids, you can see.
error.
Kids, you can see.
You put something on.
Oh! The average I got 1.225.
I wouldn't think that's all,
Oh, wait, I haven't finished my coffee.
You were using the wrong.
Let's,
Wait, probably close not.
let's,
I have the right answer.
Yeah, you just put big ones
Oh,
right
wait,
there.
Well, if he's right.
can you get a test sheet?
Hey, have you finished your number 8? Correct, number 8.
Oh yeah, Andrew, I left a little
Mr.
something
Kenny, I'm a
over
little
there.
confused.
Okay, y'all finished through number 8?
Yeah, we'll just do this.
What does this mean?
I'm getting at most 3 correct. So 3 or less.
Ah.
At most 3, right?
Yeah.
Okay. Alright. So, I want to show y'all one thing really quickly that can speed things up, and Andrew accidentally discovered this. So really quick detail, if you go through and go to distributions, and you do binomial PDF, so we had 5 trials, probability of success of 1/4. Notice how it says X value is optional. If you just hit OK at this point, do those numbers look familiar?
Yeah.
Okay. So you can do the individual values, okay? Or if you leave it optional, notice this is the probability that X equals what? This is the probability that X equals 0. This is the probability that X equals 1. This is your probability that X equals 2. Probability that X equals 3.
Wait, how did you do that?
Man, it's a good thing that I just explained it, isn't it? Thanks for paying attention, Star.
I was
Okay. Well, maybe when I start talking, you should listen. All right. Really quickly, notice I can't see X equals 4, X equals 5, but if you scroll to the right, you can now see it. So there's 5 and there's 4. So you have to go up till it's highlighted, and then you can scroll through them and see what you're missing. Okay. All right. Has everybody done the mean and the standard deviation yet?
Yes.
Is there anybody who hasn't gotten mean or standard deviation yet?
No.
I never
Correct. That's why I showed you this new detail. All right.
How do you interpret?
Fun fact. Did you know that you didn't even have to do all that work for the mean and standard deviation?
Don't say that. We will say it's true. I mean, listen spreadsheet.
Okay. So yeah, instead of putting all that work into the list and spreadsheets, do this for me really quickly. Oh, I'm still recording. Perfect. I'm glad I caught that. Oh, that's adorable, Dixie. Okay. How many trials did we have again? 5. Okay. What was the probability of success?
4.
1 and 4.
1 through 4.
What is 5 times 1/4?
Oh, wait. Point.
1/4. I mean,
5 fourths. What is that as a decimal?
1.5. Well, good.
Well, what was your mean?
1.5.
Wasn't the mean 1.25?
No, it was 1.26.
No, it was 1.25. That mean was definitively 1.25. Okay, hold on a second. No, that's not one. Right there, 1.25.
Did I do something right?
I will say this. What it may be is it may have been 1.26 if you rounded too much.
I didn't run that much.
Well, apparently you did. Okay, so if you didn't round at all, which I didn't, I don't know if you knew this, but you can actually put the binomial, you can actually put the binomial PDF right into there. So distributions, I just did a binomial PDF as my probabilities. That's how I got these values. Notice binomial PDF down here. Okay. So here's how it works. Like I want you to think about this. We did this when we did the 1 in 6 wins, and we talked about the bottle caps. There's 30 people in Miss Gallus's class that went to the store, and there was a 1/6 probability that each one wins, right? So how many did we expect to win? If 1 in 6 wins, and there's 30 people going to the store, we said we expected 5, didn't we?
Yeah.
Notice if we say 1 in 6 wins, is that a binomial distribution?
No.
It's binary. They either won or they didn't. Each person had a probability of 1/6 of winning. It was a fixed number of trials, and each was independent. That was binomial. And so what did we do? In that case, we did 30 times 1/6, and we said, hey, we expect 5 winners. Here, we have 5 trials, right? 5 questions. Each person has or each question you have a 1/4 chance of getting it right. Now, you do say, like, how does a 1.25 come about? Well, here's the thing. If I did many, many samples or many, many trials of this binomial random variable, I would expect to see the average be 1.2